Hey guys, today we are going to talk about binomial radical expressions, which is going to involve adding and subtracting radicals. Also, we're going to multiply radicals in binomial form. So that's what we're going to do today. We're also going to deal with some rationalizing denominators again, using the binomial of a radical. Remember binomials, what that means? A binomial means you have two terms. So some binomials you have worked with in the past would be like x plus 2, right? That's a binomial. Binomial radical means there's a radical involved in there somewhere. So it might be the square root of x plus 2, or it might be 3 square root 2 plus y. So something where there's two pieces and there's a radical involved. They could even both be radicals. Square root of 5 plus the square root of 2. That could be a radical binomial. So there's two pieces, and at least one of them is going to be a radical. Okay, so let's talk about adding and subtracting first. Okay, in order to add and subtract radicals, you must have the same index and radicand. That means the little root on the outside and the number on the inside, they're going to have to match with the other side. Okay, so here I have 3. That is the square root of 5x minus 2, the square root of 5x. So they both have, I know it's not written there, but we talked about how if it's not written, the default root is 2. They both have the square root and they both have 5x. They are both square root of 5x. It has to be exactly the same. When it is, then I can do just the pieces on the outside. 3 minus 2, that gives me 1 square root 5x, or I can just say square root of 5x. Okay. The next one, we have 6x times the square root of 7 plus 4x times the square root of 5. Now, they both have the square root, but the first one is a 7, the second one's a 5. So I cannot simplify. They are not like terms, right? If I had 2x plus x, I could add them. Those are like terms. Square root of 7 and square root of 5 are not like terms. Okay? Let's do this one. Number 3 is 12 times the cube root of 7xy minus 8 times the cube root of 7xy. They both have the cube root of 7xy, so I can do this. So I would do 12 minus 8, which is going to give me 4. So it's 4 cube root of 7xy. That like term stays the same. It never changes when we add or subtract. Okay. The next one we have 7 times the cube root of 5 minus 4 times the square root of 5. It almost worked, except this has a cube root. That has a square root technically. Remember, its index is a 2. So therefore, we can't simplify because they had different roots. Okay, so different index, which is the root. Okay, one had a square root, one had a cube root. All right. Sometimes before you can decide if you can add or subtract or not, you have to simplify the expression first. So looking at number 5, we have this square root of 12 plus the square root of 75 minus the square root of 3. Well, first thing I noticed is they all have the square root. So that's good. I can keep moving on. I can't say, oh, I can't add or subtract because they're not in their simplest form yet. So I need to simplify the square root of 12 and square root of 75. Square root of 3 is done. I can't do anything else there. The square root of 12, I can break that apart to be 4 times 3. Well, I know the square root of 4 is 2, right? This becomes 2 square root 3, okay? The square root of 75 I can break apart to be 25 times 3. I do that because I know the square root of 25 is 5, but the square root of 3 just stays square root of 3. And then this last piece, just to make me visually help me out, I put a negative 1 out in front of my square root of 3. All right, so now let's look at it. I've simplified 2 square root 3 plus 5 square root 3 minus 1 square root 3. Look at that. They all have a square root of 3. So here I can do 2 plus 5, which is 7, minus 1, which will be 6 square root 3. So 2 plus 5 minus 1. And then their like term was the square root 3, so that is still there. All right. My next one, we have cube roots this time, okay? So I have the cube root of 250 plus the cube root of 54 and the cube root of 16. So I got to split these up. So I got to try to think of the perfect cubes in my head. All right. If you don't know them, by the way, let me show you this trick. If you're not familiar with your perfect cubes and you have a graphing calculator, okay, what I want you to do, let me clear out what I have. Okay. I want you to push your y equals button right here to get your table. And I want you to do x cubed. So you're going to use this button. This is your variable button. So push that and x will show up. And then I want you to do the little caret and power of 3. So it should look like this. Okay. Then I want you to go to your table. Okay. So you're going to push second graph, which goes to your table. Okay. And you have all of your perfect cubes. So 1 cube, 2 cube, 3 cubes, so that these numbers replace the x. Here's all your perfect cubes. Okay, so there's a way to get a list of them on your calculator if you need them. All right, for 250, I'm going to break apart to be 125 times 2, because the cube root of 125 is 5. The cube root of 2 just stays. Can't do anything there. All right, the cube root of 54, I'm going to break that apart to be 27 times 2. All right, and that is because the cube root of 27 is 3. So that becomes 3 cube root of 2. All right. Then I have the cube root of 16. There's a negative outside, so negative. I'm going to break that apart to be 8 times 2 because the cube root of 8 is 2. Now the minus sign does come down. Cube root of 8 is 2, and I still have the cube root of 2. So 5 cube root 2 plus 3 cube root 2 minus 2 cube root 2. All of them have a cube root of 2. So 5 plus 3 gives me 8 minus 2 gives me 6. So that one's going to be 6 times the cube root of 2. All right, not too bad. Again, this would really help you if you need your list of perfect squares. You would do y equals x squared and go to your table, get them there. All right, number 7. It's a little bit different because there's already numbers on the outside. Okay, so all that means is that when I bring something out, if I already have a square root there or a number outside the square root, I just multiply it with what I bring out. Okay, so we have 3 times the square root of 32 and 2 times the square root of 50. So square root of 32, I'm going to break that apart to be 16 times 2. We're doing square roots now. I know the square root of 16 is 4, and then 3 times 4 is 12. So that's going to simplify to 12 times the square root of 2. Square root of 2 can't get simplified anymore. My other one, I'm going to break apart 50 to be 25 times 2, because I know the perfect square, the square root of 25 is 5. Still have the square root of 2. 2 times 5 gives me 10. So I've simplified them. 12 square root 2 plus 10 square root 2. They both have the square root of 2. I'm going to do 12 plus 10 to give me 22 square root of 2. All right, number 8. I want you to try number 8. I'm going to pause. I want you to pause this video and then come back and check your answer with me. All right, so go ahead and pause it. All right, check your answer. You should have gotten 4 times the square root of 2. All right, so 200 I broke apart to 102. 72, the first thing that popped in my mind was 9 and 8. The square root of 9 is 3. But then I realized that 8 also still has a perfect square inside. It's 4 times 2. So I can bring, so the square root of 4 is 2. So a 2 also came out with my 3. Multiplied 3 and 2 together to give me that 6. And so I had 10 square root 2 minus 6 square root 2 to give me 4 square root 2. 72 is also 36 times 2. That would have been a faster route, but if that's not where your mind goes, then there's other ways to do it. So if 9 and 8 were your first go-to numbers for the number 72, there's still a way to get there, okay? If you did 36 and 2, if we did 36 and 2, if you recognize that, then that jumps down to 6 square root 2. So I would have skipped that step, okay? but it's not necessary. That does not have to happen. Okay, so now we're going to get into multiplying, okay? But we're going to multiply binomial radicals. Before we multiply just like pieces together, now we're going to multiply an entire binomial together. Just like you would multiply any other binomial, we're going to follow FOIL, or first, outer, inner, last, okay? What that means is I'm going to first distribute, bring my colors back, there we go. I'm going to distribute the 4 to both pieces of my second binomial. So 4 times 5 is 20. 4 times 4 square root 2 gives me a positive 16 square root 2. We mentioned this last time. What's outside gets multiplied together and what's inside gets multiplied together. Okay, so both 4s were outside. They got multiplied together. All right, we're going to do the same thing, but we're going to do it with 2 square root 2. So now we're going to distribute that to both pieces. So 2 square root 2 times 5. The pieces on the outside are 2 and 5. So that's going to give me 10 square root 2. Okay, all right, it's kind of crossing over. Then we're going to do 2 square root 2 times 4 square root 2. Okay, pieces on the outside, 2 times 4 is 8. Pieces on the inside, 2 times 2 is 4. All right, now let's go through and simplify anything that I might see. Okay, I notice that these pieces in the middle both have a square root 2. I can multiply those together. I mean, not multiply, add. So 20 is still here. 16 square root 2 plus 10 square root 2 is going to give me 26 square root 2. I also notice on the end, 8 times the square root of 4, well, the square root of 4 is 2. So that's the same thing as saying 8 times 2, right? Which is 16. Now from here, I see that I have like terms again. I have 20 and I have 16. I'm going to add those together, right, to give me 36 plus 26 square root of 2. And that's as far as I can go with that one. There's no more simplifying. I can't add together 36 and 26 because 26 has the square root 2 and 36 does not. All right, so we're still foiling, still simplifying my radicals along the way, multiplying outside numbers together and inside numbers together. All right, I would like you to pause and I would like you to try this one. Okay, so pause the video, pause it. All right, check your work. You should have gotten 8 minus 2 square root 7. So what I did in this problem, because there was no really number on the outside of the square root of 7s, I put the 1 there. And that helped me realize that when I multiply negative square root of 7 with 5, technically my numbers on the outside are negative 1 and negative 5. Or sorry, negative 1 and positive 5, which gave me negative 5. And the only piece with the radical was square root 7, so it stayed. And then so my last piece, negative 1 times 1 gives me negative 1, technically, right? And then 7 times 7 gives me 49. The square root of 49 is 7. Multiply it with the negative 1. That's where the negative 7 came from. All right? There are some special cases with these, which we actually love. Whoa. Not sure what just happened there. Hold on. We were this one. There we go. There are some special cases with multiplying. If you notice here, 3 times the square root of 2 minus 9 and 3 times the square root of 2 plus 9. So they're almost the same thing, but one's positive, one's negative. If you go back to our complex numbers way back at the beginning of the school year, August, September, we had complex conjugates, right? And we used that to get rid of our i's in the denominator so they would go away. So if I have radical conjugates, we're going to use that to get rid of my radicals. Okay, so the answer here shouldn't have any radicals in there. And again, we're going to use these to rationalize our denominators, which is coming up next. Okay, so look here. And after we do one, I'm going to show you like a little shortcut. Okay, so here I have 3 square root 2 times 3 square root 2, right? There we go. 3 outside, 3 times 3 is 9. The insides, 2 times 2 is 4. I'm going to go ahead and simplify that. 9 times, that becomes 9 times the square root of 2. That is 18. Okay? Now I'm going to do it again with my end number. 3 times 9, well, that's 27. And I have a square root of 2 there. Can't do anything about it. Do it again with my inside numbers. So I have negative 9 times 3 square root 2. Do the outsides. Negative 9 times 3 is going to be negative 27. And then I have a square root 2. And then I'm going to do negative 9 times 9. Well, that's negative 81. All right, so I got ahead of myself. I did simplify this piece already. Square root of 4 is 2. 9 times 2 is 18. Okay. These both have a square root of 2, right? So 27 square root 2 minus 27 square root 2, don't those cancel? They're gone, right? And then I'm left with just minus 81. So we really only have 18 minus 81, which gives me negative 63. So if I have a radical conjugate, and the point of a conjugate is to eliminate my radicals, then all I should have left is just an integer, a positive or negative. Okay? There should not be radicals left in my answer. Okay? Let's do another one before I show you the shortcut. Maybe I won't show you the shortcut. We'll see. All right. 5 square root of 3 plus square root of 2 times 5 square root of 3 minus square root of 2. All right, so we're going to distribute the 5 square root of 3 first. 5 times 5 is 25, okay? Square root of 3 times square root of 3 gives me the square root of 9. Do it again to the end. 5 times, there's technically a negative 1 right here, gives me negative 5. Square root 3 times square root 2 gives me square root 6. All right, do it with my square root of 2, so distribute that. Square root of 2 times 5 square root 3. Well, the numbers on the outside are really 1 and 5, so that gives me a positive 5. Square root 2 times square root 3 gives me the square root of 6. Distribute one last time. Positive 1 times negative 1 is negative 1. Square root 2 times square root 2 is square root of 4. All right, we got some simplifying to do here. Square root of 9 is 3, so that really just becomes 75. These both have square root 6, and again, negative 5 plus 5 is 0, so there's nothing left there, that cancels. And this becomes negative 1 times 2, which is just minus 2. So it becomes 75 minus 2, which is 73. Okay, so just like our complex conjugates where the i's canceled out, radical conjugates, your radicals are going to cancel out, and you just have a whole number left over. Okay, this is very important when we rationalize a fraction. Okay, there can't be a fraction under the radical sign, and there can't be a radical sign in my denominator, and there can't be a perfect root under the radical. So we kind of played around with this a little bit with just like single terms of radicals on the last notes. Here, notice there's a binomial of radicals as a denominator, okay? To get rid of that, because we can't have those radicals in my denominator, we're going to use the conjugates that we just learned about, okay? Because to get rid of my radicals, I need a radical conjugate, which means I have the exact same thing, but I'm going to change the sign in the middle. And if I do it to one piece of my fraction, I've got to do it to the other piece of my fraction also. Oops, sorry. We have to use the same conjugate. So if I'm going to multiply the bottom by square root 5 plus square root 2, I have to also multiply my numerator by square root 5 plus square root 2. All right. Here we go. Let's multiply. I might share with you the trick after this one. Square root 5 times square root 5, that is going to give me square root of 25. Square root 5 times square root of 2 is going to give me a positive square root of 10. Negative square root 2 times square root of 5 gives me negative square root of 10. Negative square root 2 times square root of 2 gives me negative square root of 4. These pieces cancel, right? That really just becomes 5 minus 2. So that really simplifies to just 3, right? Look at this. What is 5 minus 2? It's 3. That's your shortcut. When you multiply by your radical conjugate, what's in your radical gets to break free. So really, you can just do the 5 minus 2, and you get 3 out of it. And you always do the minus in the middle. So that's the shortcut. Only for conjugates, though. Okay. The numerator, there is no conjugate, so I have to continue with that math. Let me change my color. Make it like green or something. All right, so my numerator, though, 3 times square root of 5 is 3 square root 5, okay? 3 times square root 2 is 3 square root 2. All right, piece in the middle, negative square root 10 times square root of 5 is going to be positive, no, I lied, negative square root of 50. And then negative square root 10 times square root of 2 is going to be negative square root of 20. All right. We have to simplify those pieces on the end. I'm going to move my face. We actually did this one earlier, the square root of 50. We know that that is 25 times 2, so that's going to simplify to 5 square root 2 right here. Here, negative square root 20, that is 4 times 5. Square root of 4 is 2. So that simplifies. I see some things I can bring together. So notice there's 2 pieces with the square root 5 and 2 pieces with the square root of 2. So there is 3 square root 5, and there's also a negative 2 square root 5. Then I have a 3 square root 2 and a negative 5 square root 2. Okay. So 3 minus 2, that gives me 1 square root 5. 3 minus 5, that gives me negative 2 square root 2. And it's all over 3. And that's as far as we can go. Notice I have a 1 in front of my square root 5. The answer doesn't. It's the same thing. You don't have to if you don't want to, or if you want to, you can. All right. All right, let's do another one. Here we have 2 plus the square root of 14 over square root of 7 plus square root of 2. So, again, to get rid of my radicals, we're going to use the radical conjugate. So in this case, it is going to be the square root of 7 minus the square root of 2. Do it to top and bottom. All right. So let's multiply. I'm going to do my numerator first. So 2 times square root of 7 gives me 2 square root 7. 2 times negative square root 2 gives me negative 2 square root 2. 14 times 7, what is that? 14 times 7. That's going to give me the square root of 98. And then square root of 14 times negative square root 2 gives me negative square root of 28. All right, my denominator, because I know my trick, square root of 7 plus square root of 2 times square root of 7 minus square root of 2. Shortcut, I know it's going to be 7 minus 2. Okay, I need to simplify some pieces. I don't think I've done any of these before, so I'm gonna do it over here off to the side. So I'm gonna simplify the square root of 98. Square root of 98 simplifies, let's see here, so 49 times 2. So that means it's the same thing as saying 7 square root 2. So 98 becomes positive 7 square root 2. All right, my other one, negative square root of 28. Well, that is 4 and 7. Square root of 4 is 2, so a 2 comes out. Right, the minus sign was already there, so we're going to keep it there. Okay, so that was just some side work to simplify those radicals. Okay, so I have 2 square root 7. I also have minus 2 square root 7, right? Boom, boom. And then I have minus 2 square root 2 and positive 7 square root 2. This one and this one. All over 7 minus 2, which is just 5. All right, 2 square root 7 minus 2 square root 7 cancels out. Negative 2 plus 7 gives me 5 square root of 2 divided by 5. This happened last time. Numbers on the outside are allowed to simplify. So 5 over 5 actually cancels out. And guess what? My answer is just the square root of 2. That is it. Okay? I have another one. Number 15 is a little different. We have just the cube root of x down here. So we have 2 plus the cube root of x over being divided by the cube root of x. You cannot do this. Okay? They cannot simplify. This does not equal 2. Okay? Because of the binomial, because of that plus sign, this one right here, you cannot cancel things. If the plus sign was not there, if they were together by a product or multiplication like this, then you can cancel out because you're dividing. All right? It's a whole number with a whole number. Okay? That's not happening in number 15. There's a plus sign here. So because of that plus sign, it changes the entire thing. All right? I am going to recognize, though, the bottom. I have a cube root of x, which we talked about last time. There's 1x down there, so I need 2 more. I'm going to do that to both top and bottom. Remembering that this is a binomial means when I simplify, I'm going to have to multiply 2 times the cube root of x squared, and then plus cube root of x times cube root of x squared is the cube root of x to the power of 3, being divided by cube root of x to the power of 3, because when we multiply my insides, x times x squared is x cubed. Now, the whole reason why we did this is because cube root of x cubed is just x, right? So my denominator is just x. That's why we do that. 2 times the cube root of x squared, I can't do anything with that. That's the same. Cannot simplify. But look here again, cube root of x cubed, that is just going to be x. And if I rewrote this as power over root, see how that just becomes x to the power of 1, so it's just x. And again, I cannot cross things out because of that plus sign, so this is my answer. There's nothing else I can do. I have my 2 cube root of x squared first. Answer has it second. It doesn't matter because of adding. Order does not matter as long as the signs stay with it. All right. Oops, sorry. Pressed the wrong button. There we go. 16. We have 3 divided by 2 plus the square root of 6. Woo! I'm going to use the radical conjugate. So that means I'm going to use 2 minus square root of 6. 2 minus square root of 6. Let's see what happens here when I multiply. So 3 times 2 is 6. 3 times negative 1 square root 6 gives me negative 3 square root 6. My denominator, 2 times 2 is 4. 2 times negative square root 6 is negative 2 square root 6. Then I have positive 2 square root 6. Then I have negative square root of 36. All right. Not changing the numerator. I'm just going to simplify my denominator. Negative 2 square root 6 plus 2 square root 6 is going to cancel out. The square root of 36 is 6. That becomes 4 minus 6. So we have 6 minus 3 square root 6 divided by 2. Oh, it should be negative 2. Yep. The reason why I cannot simplify 6 and 2 is because of that minus sign again. Everything on the outside would have to simplify. The 3, the 6, and the 2. That's not happening, okay? Everything on the outside would have to cancel for me to simplify, which is not happening here. All right? All right, there's 4 more just like those. We're going to take them step by step, and you're going to try them by yourself and then check your answers with me. Okay, so the first one is number 17. 7 plus the square root of 5 divided by 6 minus the square root of 5. Okay. This one matches up with problems like 13 and 16. More like 13 and 14. I would relate to those for these problems. So I want you to pause and then come back, and I want you to check your answer. Okay? All right, check your answer with mine. You should have 47 plus 13 square root of 5 divided by 31. So I've shown my work here. I multiplied by the radical conjugate. I combined like terms. I simplified radicals, and then I added, and I got that. Nothing to simplify because 47, 13, and 31 cannot all be divisible by the same number. All right, here's another one. Pause and come back and check your answer. This one I would relate to the one we just did would help. Number 14, I would say, is the most like this one. So I want you to pause and try it. All right, so check your answer with mine. Multiply by the radical conjugate using 4 minus the square root of 10. Distribute, multiply, combine like terms. I noticed here I have negative 1 square root 10 minus 8 square root 10, right? Oops, sorry. This right here, they both have a square root of 10. Negative 1 minus 8, that's where my negative 9 came from. Negative 2 times negative 1, technically, is this positive 2. Square root 10 times square root 10 is square root of 100. So that became 2 times 10, which is positive 20. Oh, I didn't write my 6. My bottom, negative 4 square root 10 plus 4 square root 10 canceled out. Square root of 100 is 10. That became 16 minus 10, which is 6. We got 24 minus 9 square root 10 divided by 6. All the numbers on the outside, 24, 9, and 6, can all be divided by 3. Okay, so when I do that, it simplifies, and I get 8 minus 3 square root 10 divided by 2. And that is our final simplified answer with no radicals in the denominator. All right, so that was actually our last problem. I thought we had 2 more, but we do not. So that was the last one. You have an assignment. I have a picture of this up on the assignments tab for today. So page 378, numbers 11 through 35, only the odds. So the picture has all of them. So don't do all of them, only do the odds. Okay, don't do the evens. If you want to do the evens, that's your choice, but I'm only grading the odds. All right, so let me know if you have any questions, and I'll talk to y'all later.